Okay, hello everyone. My name is Xu Zhang, an applied scientist from Amazon. And we already hear like a lot of great presentation in both landmark, semantic retrieval, and artwork. And today I would like to start a new topic, which is very useful in our everyday life and also very important research topic in instance level recognition. And that is product recognition. And I'm happy to announce here, Amazon will release a new product recognition challenge earlier next year with a brand new data set. And today I will introduce some preparation work we have done for this challenge. And first of all, let me introduce the team member in Amazon who make this challenge possible. They are Jie Feng, Yue Wu, Pradeep Natarajan, Mashu Gurumin, Maxine Lapkin, Michael Donaser, Shifu Chang, Robinson Paramuchu, Kartik Ramakrishnan, Arindan Mondo, and Prinata Rajan. Okay, so today's presentation will contain this 7 parts, and I will cover them one by one. Of course, first of all, I would like to thank you to the sponsor, which is my company, Amazon. So what is product search? So basically, just given a query image, we're trying to find what's the product shown in that image. And here is an example in the bottom. And here we have a query image which contains like a small black devices which has a screen. And we want to upload this image to our algorithm. We expect our algorithm to tell us it is an Echo Show, which is a Alexa devices from Amazon. And why product research is so important. So our company is working on very hard every day to improve our customer experience. But as an end customer myself, I often found it is very difficult to find the exact product I want. For example, here is a mark in my hand, so I'm not sure whether everybody can see that or not. I found this mark in one of my friend's home, and I just noticed it is quite beautiful, and I want to find the exact one. Okay, let me show you some detail of this mark. It's here. Okay, we probably can know, okay, first of all, it's a mark, and if you are a fan of Game of Thrones, and you may know, okay, this mark is probably related to Game of Thrones. So with current traditional text-based product search, I think the best thing we can do now is to input Game of Thrones mark into the search window and hit search. And if you can see, there are like 500 results are returned. And unfortunately, the very first one are none like related to the actual mark I have in my hand. But lucky enough, really go like all the way down, you may be able to find the one, but generally it's not the case. But I will give you another example that basically this traditional text-based search just doesn't work. And before this COVID-19, my wife and I used to go out very often. And my wife usually see like a very beautiful lady, wear like a very beautiful dresses, and he will ask me a question, okay, where I can buy these dresses. And I believe that's a question that will be asked for like all our husband and boyfriend. And as you can imagine, so with like traditional text-based product search, so that question is basically impossible to be answered. For example, if we search like orange dress into Amazon, and they will give us like 30,000 results of orange dress. And you see like into the detail that none of them is actually the exact one showing in this picture. And I believe if I send all the search results to my wife, he will be crazy. Okay, so if we can actually have this image-based search, which means we can upload either this JS image or this like mark image into our search engine and let the search engine to get information from the mark and from the JS and help us to search the product, we may have better chance to get the exact product we want. So, and that's the reason why we need this image-based product search. Okay, let me get back to slides. Fortunately, there are already a lot of like online retailing company having this image-based product search system. And here I show an example with Amazon. And there's, if you open like Amazon app in your iPhone or Android phone, and there is a function that right next to this text search window, there is a camera there. And if you hit this camera, and you can like either upload a live photo or select a existing photo in your camera roll and let the product to search for you. So this is pretty good. And a lot of the audience may ask, okay, this sounds like very similar to conventional object classification or image retrieval, which has already been researched for like multiple years. So why this product search different from all this? So the product search is actually a very difficult problem in industry, and there are several reasons. And the first of one is the number of catalog is extremely large. For example, Amazon sells like millions or even hundreds of millions products in US. And comparing to ImageNet, which contain maybe 1,000 or 10,000, and MS Coco, which is 80, this number is like crazy. And this not only like a huge catalog list, the catalog is also like diverse. Which means Amazon basically selling almost everything you want, from jewelry to grocery, from furniture to clothes, which covers almost everything. And the whole catalog list is changing every day, with new product adding every day and old product getting deleted every day. So this is very different from the conventional classification problem. And as a nature of all this instance level recognition, it has like a very long tail distribution. And most of the products only have say like 1 to 7 catalog image. And many of them only have like 1 images. And with such a large number of category, plus each product only have like very small number of images, which make learning the such a model very difficult. And what's more, so the product search is definitely a fine-grained category problem, because many products may look very similar in experience. And here I show 4 products here, which is the first generation of Echo Show and the second generation of Echo Show, and Echo Show 8-inch and Echo Show 5 inches. And they're all like looks very similar, especially for the second one, the third one, and the fourth one. And the only difference here is the second one is actually 10-inch, and the third one is 8-inch, and the final one is 5-inch. However, if you shoot a picture and show the picture there, it is very hard to distinguish the size between different products. So this will make our recognition or like retrieval algorithm really suffers from that. There's still some other issues. For example, the domain mismatch. We all know the catalog image and customer query image could be very different. And here I just show 2 groups, one group on the left and one group on the right. And within each group, and the image on the left-hand side is a catalog image. And the image on the right-hand side is a customer image. And as we can see, all these catalog images are basically professional shooted and well edited, which means the view angle is always perfect. And also the background is very clean and the lighting condition is very good. On the other hand, if you see this customer query image, it's not always the case. And the customer query image often shoot with cell phone, and the view angle may not that perfect, and the lighting condition may not that good. And also they may have like very cluttered background, which is very different from the catalog image. And how to fill this gap between the catalog image and customer image could be very interesting. And there's still more challenges there. For example, the diverse reference image, which means the catalog image may not actually contain the actual product to be shown here. So this may refer to training image noise. For example, here I show like 5 product image for Echo 3rd edition in Amazon.com. So the first 2 image, which is very good because we have the actual product in the image. But unfortunately for the third one, we still see the shape of the product, But unfortunately, it is not the real appearance of the product. It is more like a design graph, which shows the speaker inside the devices. And what worse is for the fourth and fifth images, because these two images are actually showing the use case of this product. It's not actually showing the product itself, and the product itself is not in this image. All this problem makes the training algorithm very difficult to design, how to handle all these issues. Okay, and the final problem, which haven't explored a lot in current product retrieval search, is the unstructured metadata. As we all know, in the online website, when we show a product, we are not only showing the product image itself, we generally also have a title for the product, which is a brief introduction of the product and a detailed description down below. Unfortunately, all those tags are kind of like free, unstructured tags. And you see these two products, one is the kettle, the other one is the pencil. This kind of description are quite different and quite different from each other. And how to use this useful information and how to use this information to improve the recognition performance is a very interesting problem to explore. Okay, so let me give you an official definition of what the problem we want to tackle in our challenge. So basically it's named product retrieval. And which means if you're given like a product the image for query, which is the image on my left-hand side, we want to retrieve the top K data set or catalog image that exactly showing that product, which means in SKU stuff. For example, if you use this image for query, you may get this 4 products, and maybe the first 1 or 2 are very good because they are showing the same product. However, for the third and fourth one, also the product looks very similar. They are like probably different version, but they are still considering not correct because they are not the exact product itself. Okay, and why we are doing this product retrieval instead of doing this classification problem? And as I mentioned before, first of all, the number of products is extremely large. We are talking about like billions or even hundreds of millions of products. And training a classifier with such a huge number of categories can be very challenging. And the second issue is that classification usually requires a predefined list of known products, which is infeasible in our cases because our catalog list keeps changing every day with new product added and old product being deleted, which means we really require our product search algorithm has the capability to deal with the unseen products. And that's the reason why we do this problem as product retrieval instead of classification. Okay, so how we plan to collect data and doing this challenge. So let's go to the data collection part. For data collection part, we plan to collect 4 subsets, 1 training set and 1 Gary set or index set, and 1 query set and 1 destructor set. And I will cover all these 4 subsets later on. So how can we collect this catalog image? We are meaning using master image services. And it is a services that provide to our sellers to shooting this catalog image. We basically have like 25 more professional image studio worldwide, which help our sellers to shoot like 2D images and videos and even 3D models. And these services produce 3.5 million images per year, which is a very good source for the scale of our problem. Training set. So we plan to get like 1 million catalog image or retailer images from AIS. And this is about like 100,000 products. And all these images are taken with different view angle, different background, and with different lighting conditions. And as a nature of this problem, so all this training data set will have long tail distribution, and they will have like diverse reference image, which means training image may be noisy. And we also like release the product title to the participant, because we already see how our participant want to use this metadata or text information into this challenge to tackle this problem. The gallery set. So we plan to get another like 20,000 to 50,000 catalog image from AIS. So the product here could be different from the training set, which we want to simulate this unseen product. And we will manually clean to make sure the images in this gallery set will actually contain this product. And this data set will use for development and also evaluation. And the query set. The query set is about like 20,000 product images shot by Amazon employee in the wild. Here I showed just 5 examples. I shot it in my home. And all these images, the products actually overlap with the gallery set. So basically the task will be given an image in this query set. We want to query a index image or gallery image in the gallery set. And all these labels should be manually checked, and the data set will use for development and evaluation. And to make this challenge more challenging, we also propose to collect another distracted data set, which is another 1 million images, which may contain like catalog image and non-product images. And we will certainly combine this distracted data set and the gallery data set to make a huge index set for the final evaluation. Okay, that's the data set. So we're comparing our data set with all these previous product data set. And here I list 5 which are commonly used in both research and industry. And here is a detailed comparison with all this data set. And our data set is called like Amazon in the bottom. And first of all, we see this number of images, and our data set is certainly with the top tier, which has like around 2 million. And the number of product is certainly the largest one. And we are dealing with retrieval problem, and there are like 3 data sets deal with classification and 3 others deal with retrieval, which we believe the retrieval is more realistic in these issues. And our data set is quite close to our real case application, which means the training data set could be noisy. We have like diverse reference, and we contains domain mismatch between the training image and also the query image. And we will be the first data set, which product search data set that contains metadata. And we believe this can be like a very interesting multimodality research data set in the future. For the challenge itself, we are thinking of having 3 different checks. So the first check is called like closed training set and image only, which means only the image data from the training set can be used for training. So this is very good for the participant with limited resources. And this is a setting that's very close to our conventional image retrieval setting, which only has images. And the second setting called closed training set, image and metadata, which means our participant in this check can use both the image data and the metadata in the training set for training. So this is actually pretty good for multimodality research, and we want to see how our participant would like to use this metadata to boost the performance. And the final check is called open image set, in which the participant can use whatever training data they can find. It's not only the training set we release, we can actually leverage like external training data in this challenge to see what will happen. So here we really want to see how we can push the state-of-the-art product recognition algorithm to this real-world problem. Other informations, we plan to launch this challenge in next year, Q1, and all data set will be released to the challenge participants subject to the context rule. So very similar to Google Landmark Retrieval challenge, we will also have 2 different phases. And during the training phases, the full training set will release for model training, and part of the Gary set and query set will be released for validation. And for the validation phase, we also do this model uploading stuff, which means the participant only need to upload the model, and the Amazon will run the evaluation for all participants and release the final result later. That's probably everything for the challenge. And what's in the future? So we actually have several ideas to chase in the future. The first interesting idea I have is the multi-modal product search. So this is a very realistic scenario. For example, if I see a toaster, which is pretty nice, but it can only like toast 2 slices of bread. So I suddenly want to search, say, I want a toaster which is similar to the one in the image, but can toast 4 slices of bread. So this is kind of like a fuzzy search. And the second thing is that because having like a clean product image is not very easy, so we definitely want to enable both the spoken and the text query, including the image. For example, I just shoot a image of my whole table, and then I just ask an additional comment, can you font this coffee mug on the table? So that's another thing we are thinking about. And, and all these things definitely require us to collect a very comprehensive annotation for the data set. And that will be like very challenging. And the other thing we want to do is to how to handle like multiple products in one single image. And that is very useful if I go to a supermarket or go to a mall, because when you shoot like one image, they will contain like multiple products. And how to detect all the product and recognize all the products could be like very challenging. And the third thing we are thinking about is to leverage the video information and the 3D model in this problem. Because the video and the 3D like video images or 3D model are widely available for many products in Amazon, especially for the furniture. And we believe if we can use all this information, so we will certainly further improve our product recognition performance. Okay, I think that's probably everything from my side. Happy to take questions.
Thanks, Xu. So reminding everyone, if you're attending, feel free to add questions with the Q&A function in the Zoom. I have a quick question for you.
Sure.
Have you thought, we have these different tracks, let's say, in your challenge, where you allow external data, where you don't allow external data. Have you thought of a way to actually enforce this? Or because it's hard to constrain that, and guarantee that the model that is submitted to the closed training set really only use the the allowed images.
Right, that is something we are still thinking of how to force this to happen. So certainly for the search check, we don't really need to constrain anything because that is open. For the closed one, one thing we can think of is actually constrain to have like different separate data set, and one with metadata, the other one without, but the image are quite different. In that case, we may not just using that images. But overall, I think that's a very good question, and we certainly need to work further on that.
Yeah, so based on our experience with the landmarks challenges, actually one reason why we don't set any restrictions on the training set is because there is no way we can think right now to enforce it. So people can actually use any data for the challenges. One other thought is, there are some platforms now that allow you to actually restrict the training environment as well. Where for example, you need to train within a certain environment and only has access to some data that is there. So that would be a way to guarantee something like that. But yeah, just some thoughts for brainstorming.
So I have to talk to AWS to ask them to give me like enough money to run this.
That would be one idea. Yeah.
Yep.